All right, well, thanks everybody for coming. Welcome to this DAX 50 session. How many of you have done 100 level sessions before? Do you want to know what that kind of 100 level thing means? Hands up. So 100 level means it's a real introduction, it's real basic. Well, this is really, really basic. This is like 50 levels. So we want to give everybody an opportunity to really take those very, very first steps into DAX. My name is Will Thompson. I'm one of the program managers on the Power BI team. And amongst other areas, one of my main areas of responsibility is the DAX language and the modeling tools within Power BI Desktop.
And my name's Matt Allington, and I'm from Australia, as you can probably tell. So we have a POM and an Aussie here. I don't know if POM translates that well, but that's what the Aussies call the British. And I'm an independent consultant from Sydney, and I do a lot of blogging and a whole lot of other stuff, but it's always, go Aussies, it's always Power BI focused. Okay, should we talk about the agenda for today?
Yeah.
So here's our agenda. We're basically, as Will said, we're going to go right back to basics, and we're going to start off just with a simple definition of what DAX is, and then we're going to talk about calculated columns and measures, because these are really the things that you need to be able to do to be able to turn your raw data into something that's more useful. Of course, you can drag and drop columns just like you can in an Excel pivot table, but if you really want to be good, you need to be able to write calculated columns and, more importantly, measures. We're going to do a brief introduction to the calculate function. It's the most important function in DAX, and it's also the most exciting function, and it can also be the most miserable function if you can't work out what the hell is going on, but that's another whole conversation. And then we'll sort of wrap up with some relationships. I think Will's going to show us some of the new features of quick measures. So that's pretty much the script for today. So let me get into it. So let me start.
Just going to interrupt. One or two little housekeeping things. It's wonderful that you're taking photos. You're more than welcome to. Everybody will be able to get the deck and the demo files afterwards. So don't feel you need to scribble down everything that we've got on the slides. Don't feel that you need to video us as we're going. I think even all the sessions are being recorded and you'll be able to see them afterwards.
Yeah, absolutely. Okay, so let me start off by just an introduction of what is this term DAX. Well, DAX is a shortened version of the word, or the words data analysis expressions. And so there's a bit of a history of this sort of naming convention at Microsoft. For those of you that maybe have a bit of a SQL background. Actually, let me know who sort of has more of a SQL background, who's got, so SQL background first. Okay, so maybe half the room. And can I assume the rest of you have more of an Excel style business background? Give me a show of hands on that. So, okay, so about 50-50, so that's great. So, yeah, so this sort of DAX word is sort of very similar to MDX, multi-dimensional expressions, which is used in the SQL world as most of the SQL folk would know. The main difference between DAX and MDX is that DAX is accessible for people like me, an Excel guy, right? Whereas MDX, that's a career job in IT. Like if you're not doing a career job, you're not doing MDX that well. So that's what makes DAX such an exciting language. So it's a functional language. And by functional language, what I mean is it's a function. It has a word which represents the function. It's got some brackets, and then you pass parameters to the function. And why this is important is that Excel is a functional language too. You know the sum function. You know the average function from Excel. And DAX uses very similar syntax in many cases. It's not always the same, but in many cases it's the same syntax. And so this idea of the functional language comes from the Excel world. But it was actually built by the analysis services guys from Microsoft, guys and girls, I'm sure. And so they've brought all of their database skills and knowledge, but they came in and built it with the Excel user in mind. And that's why it's so accessible to us people who use Excel in our profession. And so often you'll find that the syntax is the same, but in many cases the syntax is similar, and that can be a little bit confusing. So it's not always a one-for-one match. So you sort of have to keep your eye out for when there's a slight difference in the syntax. And then, in addition, there are brand new functions that just don't exist inside Excel. And so you have to learn them from scratch. And some of those are harder to learn than others. Some of them are pretty easy to learn. But, I sort of talk about when I teach Power BI and Power Pivot specifically, which is the sort of underlying technology. I teach people that you can't necessarily incrementally learn this off of an Excel base. You need to just invest some time up front to get the foundation down. Once you've got the foundation down, then you're off. Then you can incrementally learn from there. But to expect to know how to do an index match in Excel and then the next day build a data model in Power Pivot, that's not realistic. So invest a little bit of time starting here today and following up hopefully with some other sessions. And then once you have just a piece of technical understanding of how this works, you can then incrementally build from there. The main difference between Power BI and Power Pivot, which is the technology, is that it's a database. It's a reporting database. And for the SQL folk, maybe the SQL people who use relational databases, you would be familiar with the optimizations for storage and transactions, whereas Power BI is a reporting database. It's not the same thing. And you certainly shouldn't just be bringing in all your tables from your relational database straight into Power BI because you're going to have a bad experience. And I make a lot of money from people calling me saying, I just got a problem with this formula, and their actual problem is they've just imported their transactional database into Power BI. So we're going to talk about that a little bit today. What's it for? Well, DAX, the language, is designed to help you turn your raw data into something that's more useful. I describe it as like an insight. You're building business insights. You're taking your knowledge of how the business operates. A good example would be if you've got a transactional system that has the sell price and the cost price, it doesn't have any information in that database about what's the margin, how much do I make per transaction, or what's the margin percentage. And those additional things can be created using the DAX language. And what you're doing then is you're taking your understanding of the business rules and your understanding of the DAX programming language, and you're combining them together to build something that's more useful than the raw material, which is cost and sell. DAX also can be used as a query language, and we're not going to cover that here. But in my experience, what happens after you go down the journey and you start to build this really useful Power BI database, at some point in time, you want to get a subset of that data out for another purpose. And once you want to do that, then is the right time to start to learn about DAX as a query language. So there's an opportunity there. Okay,
what is it not for? And it's good to understand what's kind of out of scope and what's not worth spending your time on. One of the biggest confusions that I see people having within Power BI Desktop is when to use this thing called M versus DAX. So who's heard of M? Okay. Who's written anything in M? The much smaller number, good. So M is the query and transformation scripting language that sits behind the query editor window in Power BI Desktop. So it used to be part of Power Query. That's where it came from. So when you're connecting to your data, and as you're bringing in, transforming that data, maybe merging it with other data, before it gets loaded into Power BI Desktop. M's very much that step-by-step kind of transformation language. DAX is not that. DAX is about enriching that data model, adding calculations, typically adding more data to it that didn't exist in your data before. So it's important to kind of understand, don't think of it as that data transformation piece. And the other thing is there's no kind of automation in terms of UI or application flow control in it. This is about adding more columns or calculations to your data model once you've loaded it.
Sorry,
right.
not concentrating. Okay. Calculated columns, so.
Yeah, so let's start with that. Calculated columns are a simple way to add new bits of data onto tables that you've loaded into Power BI Desktop. So we're talking about adding things, once you've loaded them, we're talking about typically your tables, right? Not typically, all tables have rows and columns. I talk a lot with my hands, and I always get it wrong. Rows and columns. So we're talking about adding new things onto the end of that table. And it means that anything that you do in that column is going to affect every single row in that table. And there's a couple of reasons why that's important to remember. There we go. You have one formula that defines that column, but it gets applied row by row on every row in your table. And it's only refreshed when that data gets loaded in. So Power BI Desktop will go and pull in that data, say, great, I've got my table now. Now let's go and run that calculation over each row to add those values into the column. And it will do that once when the data refreshes, and then it doesn't need to do it again until you hit refresh again, and it will go and reload all those things. And it's also important to understand that as it's doing that, it's actually saving those calculations, saving the result of those calculations, rather, back into that table. So it is adding to the memory usage that model would take up, and it's adding to the space on disk when it gets saved. Obviously, there's great compression and things going on, so it tries to minimize that, but you are adding new things on top of those tables. And it's really useful for creating these new columns. So for doing things like adding, a weekday number, or another column that says, well, is this from weekday 1 to 5, in which case it's in the week, or 6 or 7, in which case it's the weekend. So adding extra bits of information that help you as you're doing your analysis. You can use these anywhere in your charts. So when it comes to actually putting them into visuals, you can either use them as an axis, so potentially that weekday weekend thing, you may want to do total sales on your weekdays versus total sales on your weekends and see what the difference is there. But you can also drop them into the values area of your chart, for example. And if that's a numeric column, we'll sum those things up by default. You can change that, and you can say, well, do an average of all of the numbers in that column. You can also, if it's a categorical field, say, just count the number of values in there. So if I had a name column, let's take, as a really common example, I bring in my data, and it's got a first name and a last name column. I'm going to create another column using this DAX expression to do a concatenation of the first name space last name. And now I want to do a count of those and do a distinct, how many distinct users have we got based on their name? And in that way, you could use it in the values part of your charts. So let's do a quick demo on that.
So while Will's setting up that, just let me give my spin cautionary tale on calculated columns. And I actually have a blog article about this. If my blog site will be available somewhere in one of the decks, I guess. I always advise Excel users never use a calculated column or assume that you shouldn't use a calculated column unless you know why you should. And the problem is that when the Excel user gets into the UI, which Will's about to show you, you look at these tables and it just feels so comfortable. I can see the columns, I can see the rows, I know how to write formulas, and you just feel comfortable in that space. But the trouble is, exactly as Will said, the trouble is that extra columns add additional space to your workbook, so it'll make it bigger and slower, basically. And most things, not all, most things can be done in a measure, which Will's going to show you in a second. And so my general advice while you're learning, assume it should be a measure unless you know why not. So if you know why not, fine, go ahead and do a calculated column. If you don't know why not, then just make the assumption that it should be a measure. But there are definitely valid times to use calculated columns, and we're going to show you some examples for learning and development as much as anything.
Yeah, it's really good advice. Okay, so you've all used Power BI Desktop, I hope. How many of you have either gone to this modeling tab and found the new column button? How many of you hit that new column button at some point in the past? How many of you have then typed in a formula and successfully created a formula without any errors? How many of you have got as far as getting an error and go, oh, forget that, it's too difficult? I remember having many months of, oh, it's too difficult, I'm just not going to bother trying. So deal is, you type in you click your column button and you get a little formula bar. Looks very similar to Excel, like Matt said. And in here I can start typing in my formula. So I'm going to build this one that says sales amount is just the unit price times the number of units. Is a typical thing that you might do to add extra things to the columns, but be wary, particularly if you're multiplying things together that maybe are like ratios. Bear in mind this is happening row by row, and then if you sum those things up at a later date, you might not quite get the result that you think you're going to get. So again, as Matt was saying, measures are probably the best way to do it. Start with that. If you then realize, no, actually, I do need a column, this is where you come back to. So just as an introduction to the little formula editor that we have here, as you start typing, you'll get loads of IntelliSense prompts to help you complete this formula. And this will help you with the syntax. This will help you understanding what functions are available, help you understand what parameters you need to pass into those functions, et cetera, et cetera. So best practice for whenever you're writing these columns or measures is to use the table name and then the square brackets and the column name. So for example here, I'm going to use my sales amount. Sorry, not sales amount. I'm going to use unit price. Unit price, wherever it's gone, unit price multiplied by the number of units. And I can either start typing the table name, or I can type the column name, and it will give me both. And just one point, when you're going through these lists, you'll see two different types of icons, or a number of different types of icons. These ones are calculated columns, so you're referring to a column. The little calculator is a measure, so there you're referring to another measure. And you'll see things like these fx's, where you're referring to the name of a function. So again, you can see here, if I type in one of these functions, I get some nice syntax highlighting, so it shows me in blue that this is a keyword. And then I get a little tooltip to show me what that function does. And if it's something that has multiple parameters, I'll get prompts as I start to fill it in to tell me what that parameter is going to be. So in this case, the first parameter is the column name when you're summing these things. But all I'm doing is taking the units sold. I'm going to need to make it unique because I think I've already got something called sales amount in here. And then I hit return, and now hopefully, yep, here's my little column sales amount too. So that's been saved into the table. Like we said, it's been evaluated row by row, exists in the table. I haven't added to this chart yet. And to do that, all you need to do is drag it over, right? Make it a little bigger. And there's my second sales amount measure. So I've already got one here called sales amount, does exactly the same thing. And I'm just using that in these visuals. Right, so columns. Really, really simple. Forget all that, because now we're going to talk about measures, and that's where you want to focus. But potentially the first, we need to go back up.
Do you want to go back to
potentially the first 5 minutes of this talk could have been cut out entirely, and we could have just said, no, forget columns. But they are useful, and they're often where people start, so it's good to have an understanding of those. Folks who are standing around the back, there are still a few seats down the front if you don't want to be standing up all the time.
So columns are really useful when you want to do slicing on your data. So if you want to put something into rows or onto columns on your matrix, or if you want to use it in a slicer, you simply can't use a measure in that scenario. And so Will gave an example before, like a first name, last name. If you want that to be available for slicing, then you need to do it using a measure, or you can use the M language that we talked about before. It really just depends what you want. And so measures cannot be placed in those filtering locations. Measures can only go into the value section. Are you talking about this? Am I talking about this? Sorry, I didn't mean to cut in.
I think I was going to.
Yeah,
so
go for it.
Actually, Matt hit exactly the first bullet point, right? That measures you can only use them in that values area of the visual. So it's an important distinction to make. Do you want to hit the next one? So measures have, in the same way that columns are being added to a table, you'll see them in the field list under a particular table. You'll see measures under a particular table as well, but they don't actually really care. Measures can be moved. There's a home table thing, and you can change where it appears. And all that references is just where it appears in the field list. Measures can live anywhere in any table, and you can move them into their own table, which just contains all your measures. You really don't need to worry about that. And the thing about measures is that they're evaluated when the visual gets rendered, and they're always filtered depending on what visual you're using them in. So if you've got a table, they'll be evaluated once for each row in that table. If it's a chart, they'll be evaluated once for each data point in that chart. If it's a scatter chart, and you've got thousands of points on there, it'll be evaluated thousands of times for all of those points. They're calculated on the fly. So all you're defining is the actual formula of that measure, but it doesn't store any data. So they don't add much to your file size, a couple of K to just store the string. And that means that you can, like I said, you can use them everywhere. They get evaluated many, many times without having to blow up the size of the model. And basically, they're useful for everything, really. Whether you're calculating totals or ratios, or even doing things like moving averages, there's time intelligence formulas in there. You could use them to produce strings that you can use as dynamic titles and kind of have them reference other bits of data and sum something up and then add some strings around it and use that as a title. You can do all sorts of things with them. Really useful. Now, these are typically the ones where people kind of struggle, whether you're coming from an Excel or SQL background. Slightly less intuitive, perhaps, than the calculated column, but they are really the secret sauce. They are really, this is why you need to go ahead and learn these. Very useful. All right. So I'm going to do a really simple demo. Just use this to sum up a column. I'm going to put it into a visual, and we'll look at how it's being filtered, how that measure is being filtered and evaluated both within the visual, but then also filtered by things coming from outside the visual. We'll see how that measure reacts. All right, so we'll do a really, really simple demo here, just summing up the units column. So this is going to be how many total units did we sell? So here's my oops, zoom in. Here's my formula for this one. I just used that sum function and then passed in the column name. That make sense? I mean, hopefully it does, because this is the simplest one. I can't make it any easier. And I'm going to use this in a couple of different visuals. This first one here is just a card where it just says, go and look at all of my data, go to that units column and sum everything up. And I get 116,000. So in my database, I've got about 30-odd thousand rows. And for each transaction, each row in that database, I've got multiple units being sold. So I get this number of 116,000. So let's start using a slightly more interesting visual. Not much more interesting, it's only a table. But now if I drop that same measure onto this table, I'm now going to go and evaluate that measure for each row in this table. So we go to the audio row, and we say, OK, database, give me all of the rows out of the database that correspond to the value audio. So what the engine's doing is it's going down the category column, and it's looking, does the category equal audio? Yes, OK, we'll give you that value. Does the category equal next row, does the category equal audio? No, it doesn't. OK, I'll forget that one. And all those rows that get sent back up then get summed up. And you get a value of 8,643. Then we go to the next row in the table, cameras and camcorders. Right, scan through the table. For each row, for each value in that category field. And this is, many of you who are from a SQL background, you might be thinking, oh my God, so many table scans. It's OK, because this is a super fast in-memory, blah, 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 column-based database. That's why we do it. You don't need to worry about that. All you need to know is your numbers get summed up. Now, something interesting happens when we get down to the total row. Here, we're saying, OK, I now care about all of my data again. Ignore the fact that I was filtering for each category. Just go and get me all the data and run that measure over every row in that table. And it's a really important distinction to understand, because we're not just saying, take the numbers in this table and sum them up. We're saying, go back to the underlying data and sum that up. Now, in the case of a sum, it wouldn't make a difference. But if this was doing something a little bit more complicated, like some ratio or some other much more complicated function, you might get different results. So you might get a different number by evaluating it once for each row in this visual, and then adding some calculation on top of it, versus going to the underlying data and evaluating it across all of that. Does that make sense? Because it's really important to understand. We see many, many questions on forums and on Twitter and bugs being filed where people saying, the numbers don't add up. It's because we're not just adding the things in the visual, we're actually changing the calculation.
So the important point that you want to take out of this is that the visual filters your data. And a very important concept that I've found it's useful to try and develop is to be able to imagine these tables in your mind, almost like you can almost see it in your mind. And so when there's a filter on this column that's product category is audio, imagine that big table, however many rows it's got, has now got a filter applied, and I'm looking at a filtered copy of that table. And the way Power BI works is it applies the filter first, then it does the evaluation second. So if you get used to doing it that way and say filter first, evaluate second, and as Will said, the grand total row is no different. The only difference with the grand total row is there's no filtering. That's the only difference. Otherwise, the process is exactly the same.
So filters can obviously come from multiple places. They can come from within the visual, where we're filtering each category. But I've also got a slicer here. So if I choose just the deluxe products, we're doing two filters. So think about Matt's analogy there. It's a big table. I'm going to filter to just the deluxe products. And then I'm going to filter to just the audio products in that deluxe table, and now I'm going to evaluate that, and you get 954. And actually, the order in which those filters are being applied is important. We've either got or we're in the process of writing up a documentation page that explains the precedence of all these filters. But basically, it goes, I wish I could just reel this off really, really quickly and confuse everybody. It goes report level filters, page level filters, slicers, visual level filters, and then there's like measure filters under the bottom. There's a few others. Don't worry about learning that. Look it up if you ever need it. But just be aware, you've got filters that then filter the filtered set, and then you get those things being evaluated. I probably over-confused that, but hey. All right. So that's simple measures. Let's swap back to the slides.
Okay, so you've seen a couple of examples, and so far everything that we've showed you is being filtered naturally by the visual. So the visual provides filter from rows and columns, and you saw the slices. This is all stuff that's completely familiar to you and would not be a surprise. So this is the right time to talk about the calculate function. And calculate, as I said up the front, it's the most important function that exists within DAX, the DAX language, and Power BI. And the reason that it's so important is it's the only function that can modify the natural filtering behavior coming from your visual. And so if you want to see anything in that visual that is not standard, and there's such a list of examples like, for example, give me the sales from last year. Well, if you've got a filter that says it's currently June 2017, and you want to see the sales for last year, well, how can you do that if you've got a filter that says give me June 2017? You need some sort of trick to go back in time and fetch the number from a previous period, and calculates the function. We call it the secret sauce. And so what calculate does is it modifies the filter context. That's the most technical we're going to get. It modifies the natural filtering behavior of the visual, applies the filters that you specify, so now no longer are you stuck into the matrix with columns and rows, but you can add anything on top that you want. Another way of thinking about it, it's like the go apply filters function. Probably, that would be a better name for it, actually, go apply filters.
Apparently it was debated in the team. Yeah. What should we call this function? Yeah. Apply filters. Yeah.
So it gives you an opportunity of getting a different outcome than you would naturally get from your matrix or from whatever your visual you've got. And that's what unleashes the power of Power BI Desktop, in my view. This is the way I like to describe it. I won't point generally, but a few of you look like you might actually know what this is, and there's a few of you that look like you probably don't know, and I won't sort of point out the difference. But this is an old mechanical adding machine. This is what used to happen before we had transistor circuits and electronic calculators. And let me describe for you, for those that aren't familiar with this, how this works. And so there's these sets and rows of numbers. So on the very right-hand side, it's like the cents. And then the next row in is the 10-cent column, and then it's the dollar column, $10 column, $100 column, and so on. And the way this particular piece of mechanical equipment worked is that you would come in and you'd punch the numbers representing $125.50, for example. You'd pick those numbers in the correct column. But importantly, when you push those numbers, nothing happened. What happened was the button stuck in to indicate that I've registered that as what I want. But at this point, nothing happens, because there's no solid-state electronics. And then to make something happen, because it's a mechanical machine, you've got this handle up here on the right. And when you pull the handle, the engine grinds over, and all of those numbers that you said you want to use get applied to the adding process. And so I think about this handle as the calculate function. This is all calculate does. It just tells Power BI it's time to run the filtering machine. Now's the time to run the filtering machine. And any filters that you've applied by entering them into the filter parameters within that function get applied at that point. But if you think of calculate as time to run the filter machine, then you'll never have any problems understanding what it does. So that's the way I describe that process. I think, Will, you're going to do some examples here?
Just two simple examples. One very, very simple, where we're saying, here's this calculate statement. So I want you to go and apply some filters to something and then run a measure. And the first thing you put in is the measure, in this case, total sales. And then you can specify as many parameters as you want, which include all of the filters that you're going to apply. I'll come and talk to this side of the room because I haven't spoken to you guys yet. So the first one says, the thing that I'm interested in is sales just from the USA. So we're saying, go and filter that customer table to just where the country equals USA, and then go and calculate the total sales over the rest of it. And obviously it means you also use all of the other filters that might be coming from elsewhere in the visual, But that's the thing I care about, total sales just for the USA. And the second one is just same function, formatted slightly differently. And this is where you'll see I've got two filters being applied. So we're saying go and filter the calendar table to just the 2017 year, and the customer table to just the gender equals M, and then go and run the number of new customers measure over the top of that. Now we're using things from multiple tables here. Matt will talk a little bit about multiple tables and relationships in a second. But this could equally be done if you've just imported one table of data as well. It just means that all your columns will be coming from the same place. So that's it. Calculate just says, here's a measure I want to evaluate, and here's the set of filters that I want to apply first.
Maybe I'll just also point out, I will mention this up front about always specifying the table name in front of your column name. And you'll see that here in this first example. So it says, calculate total sales, comma, followed by customer, square brackets, country equals USA. And this is exactly why we always put the table name in front of the column name, because I can look at that particular function and I know that country is a column. The only reason I know that is because it's got a table name in front of it. And if I can look at that total sales and I know that that's a measure. If it had a table name in front of it, I would know it was a column, and it would actually fail in that case. But it's a really important distinction. It's great to get good, to learn good practice when you start to use a new tool. Now we're fortunate because the dev team done a great job with the IntelliSense. So if you even start to type the country name, it will automatically add the table name in front for you. But if you're using Power Pivot for Excel, which fantastically is exactly the same engine, it's a little bit less developed as far as the latest features, but it's exactly the same engine. It's not so helpful in the IntelliSense, it's not quite as developed. And so I particularly see lots of people making that mistake when they start off in Excel because they're not putting the table names in front. And then as you get into more advanced DAX outside of the scope of today, it really can make a difference. If it's a column or a measure, you get very different behavior. And so you need to be able to instantly tell which is which. So that's good practice.
Go to the next one. And then, so there's a slightly more complicated one. So I'm using the calculate bit. That's the bottom 3 lines plus the right bracket. But I've also got just a reference to the unit sales measure above it. And this is saying, I want to know what the difference from today's value is. Well, the date that I'm specifying there is 2017 and 0503, so the 3rd of May, 2017. It's not the 3rd of May today, is it? No. So it's saying, go and calculate the unit sales for 3rd of May 2017, but then subtract that from the unit sales for everything. Make sense? I'm hoping, right, hit me next.
Yep.
I see, have you ever seen this image before? I see so many like tutorials and things that are like this. Here's something really simple, now just draw the rest of the owl. I hope that's not super confusing for everyone, right? So I'm going to try and step through this nice and slowly. This is a 50-level session. I want to make sure that everybody, this has time to sink in. Because as we've been saying, the calculate function really is the core of being able to write DAX. So I'm going to start actually with a slightly different calculation. This one just does a simple filter to say, I only care about my deluxe products. So it's really, really simple. Where has it gone? Deluxe unit sales. So just calculate the unit sales, but only where the class column is deluxe. So it's being evaluated here. I've got my kind of naked unit sales, if you will, as well as the deluxe unit sales, just so you can compare. So for each row in this table, again, as Matt was saying, it's filtering. In this case, we've got 2 filters being applied. We've got filtering down to just December 31st, 2015. That's my first filter. And now I'm going to go and evaluate my measure. And I look at the measure and I go, okay, so your first filter is for the deluxe products. So I filter down that set of rows to just the deluxe products. And now I do my unit sales, sum of unit sales. So I just get the sum, and there's only 7 on this for this date. So the crucial thing there is that the calculate it's not replacing all of the filters. It's actually enhancing and adding to the filters. As Matt decided in the description, right? Calculate can do 2 things. It can either add filters or it can replace filters. In this case, we're just adding them. So we're doing one set of filters on date and then another set of filters on class. So let's look at another one. So let's take that day-by-day kind of example. And here, this is interesting because we're replacing the filters. We're changing the filter. So here in my table, I'm still looking at individual order dates, but I've specified in my calculate function an order date as well, the order date column too. So here it's saying, right, so firstly, let's go and filter the data down to just October 17th, 2011. And then we look at what's in the calculate function, and we go, you're asking to change the filter on order date. And now you want to get me the values for the 1017, 1017 2011. Now on this first row, it's actually the same value because that's what date we're looking for. But look at the next one. Here we're actually changing the value to be October the 19th. So you'll see that my naked unit sales measure, I get a different value for each day. But for my unit sales on first day, it's always replacing that date filter with 17th of October 2011. It's the hardest thing for a British person to learn when you move to the US, is swapping the dates and months and days going on. But you see, we're getting exactly the same number for every single row in this table. And that's because we're replacing that order date filter with the one that we specified in the calculate function. Even on the total row. So think what we said about the total row. It's no different to any other row. For the unit sales measure, we're saying, give me all of the rows in my underlying table and sum them up. For my unit sales on first day, we're saying, yeah, I still want to filter it to just that total, just that day, and give me the sum for that day. So this is the more complicated one. Hopefully this is not just draw the damn owl. So I'm doing two bits here. So again, you'll see the bottom four lines, calculate unit sales for the sales order date, for the date 2011, 1017. That's giving me that value of 2, which we remember from the previous slide. And I'm saying subtract that from the unit sales. So now we get the difference between whatever my naked unit sales measure is, subtracted, and then subtract the calculate unit, so the filtered unit sales measure from it. So unit sales was 2. The first day value was 2, so we get 0. And then we evaluate that for each row in the table, and that's what you end up with.
If you think about this from an Excel world, so half of you are Excel pros. I often say pros, but users might be, because not everyone wants to be associated as an Excel pro. But in the old world, you'd probably build a pivot table that had the sales for one day, and then you'd end up with all of these columns that you didn't need, and then you'd either hide half of them, or you'd put it on a second sheet and hide it and point back to that sheet. Well, you can't do those sorts of things in Power BI Desktop, but you do have the power of Calculate to be able to, in a very bespoke way, come up with a very particular measure that meets a very particular need. And the developers don't mind what your need is. They've given you all the tools that you need to do whatever you want, and it gives you unlimited power, quite literally. Can we just show the table that's sitting under here before I switch to?
Okay.
So with the data model that Will's been using today, and this is the data view, you can go to the relationship view. So there's two views. There's the data view and the relationship view. So this table has just got, the table 1 has just got some measures stored in it. But basically, this is the only table of data that Will's been using in the demo so far. Now, this is exactly the way that Excel folk have learnt to do it forever, right? Because what used to happen, you used to get the transactions from the sales system, and you'd see the sales for product number 567, and you go, well, what's product number 567? Well, I don't know. So you pick up the phone to IT and you say, can you give me an extract of the product master file? And they go, yeah, which columns do you want? And you say, just give me everything because I don't know what I need, and I don't want to have to come back and ask later. And then you would load it up into Excel, and then you go down the column and you write VLOOKUP, or if you're more advanced, you might write index match, and you go and fetch, and then you've got to do that for every single column that you bring into the table, and you end up with this one great big fat single table, and then you insert a pivot table over the top. That's the way it's always been done, and it's the only way that you can do it in traditional Excel. So if we can swap over to my PC. So let me just talk about relationships, because what we tried to do here is just start with the simplest starting point, and that's one big flat table. But it doesn't have to be that way, and in fact, it's optimized not to be that way. And this, what I'm about to show you, is actually a better design. And so that design that I talked about before in Excel, where you have a single flat transaction table, and then you go and get your product table, the perfect world is that you keep those two tables as completely separate. And so you sort of have to undo what you've learnt about creating pivot tables in Excel in order to be able to do this. So I'm just give you a brief demo and show you how this works. We've only got limited time, so I'm not going to sort of build this out. But this is what the alternate design looks like. In this case, I've only got a products table and a sales transaction table, but it could easily be that you have a customer table. You would almost always have a calendar table telling you something about some information about the particular dates of the sale, and you can have as many tables as you want. And learning how to do that, what's the optimum design, is actually a job in its own right. But so here is a different version of that same model that Will showed, and so now I've actually got two tables. Believe me, it's got exactly the same data in it. The main difference is that now these two tables are two different types of tables. So for the SQL folk, the sales table is a fact table, and the products table is a dimension table. For the Excel folk, I use the Rob Colley language, which is data tables, lookup tables. And the reason I like lookup tables is in the old world, you'd go and write that VLOOKUP to go and fetch the data back, and that gives me a really good mental clue about what is in that lookup table. It's the one I used to write a VLOOKUP against. And instead of writing VLOOKUP, and when you did write VLOOKUP, you went to your product code, 456, and you said VLOOKUP, go and find this in this table, go search down until you find a match. Of course, there can only be one of everything. You can't have 5 matches, otherwise VLOOKUP doesn't work. And so in the new world, all I do is I drag from the sales table to the products table, and that's it. I've just written VLOOKUP for every single column in this products table. What's more, if tomorrow I get 5 new columns added to the product table, I just bring them in and they work as well. The whole thing continues to work exactly as it otherwise would. And so I can come in here and put a matrix, and I can quickly write a measure. Now, I do this slightly different. There's this modeling tool up here where you can create a new measure. I like to make sure they go in the table they come from, so I always right-click on the table. And so I can just create total sales, which was the one that Will created, and that's just sum of the sales. What did you did a sum of the sales amount. I think it's that one with no spaces in it. Yep. And so I can write my measure and put it on there. And I can go to the products table and bring out a category, drop that onto rows. Let me crank this up with a little bit. I have to talk to Will about the default font size being 8 point. We'll have a little chat after the break about that.
It's only for demos that it's a problem.
Yeah. And but you can see it just works, right? Now I've pulled the category table, but it could be a category column, but it could be any other column. The world of VLOOKUP is gone forever as you make the journey across to Power BI. Okay, so let's. So that's relationships. Time to talk about quick measures.
Yeah, I'll do this really quickly. So this quick measures. Who's heard of this? Who saw it in the keynote? Great. So this is a new feature, got released relatively recently, and the idea here is to just make your life easier, right? That having just told you the basics of DAX, now you can forget it, because quick measures will do it for you, yay! To a certain extent, right? They're templates that will help you get started. They solve some of the most common business problems that we've heard, and as you saw this morning, the community can submit their own ones, and we'll build those into the product too. So I've got a little matrix here. I'm actually breaking down using a hierarchy here, so I've got years, quarters, and months on this. And I'm going to use this to show a couple of different quick measures. So there's a whole range of them available in the product here. You'll see we've got these kind of aggregates per category. I'll come back to those. We've got filtered values. We've got time intelligence ones. And then there are some of these new ones that we're adding for star ratings and the concatenated list of value. This is one that Devin Knight, he's probably not here because he's already a DAX expert, submitted. So there's a few of those being added already. What I wanted to use was we'll do 2. I'll start with actually I'm going to do 3 if I've got time. I'm going to do the filtered value first. And the reason I wanted to choose this one, if I use my unit sales measure, filtered to a particular year, I don't really care what value I'm using. Oops, where's it gone? It is this one. The reason I wanted to show this was the quick measure is using exactly the same syntax. We are just building DAX calculate statements exactly the same as you would. So hopefully you can recognize this now. We're saying, go and calculate the unit sales measure for this filter. Now we use this in keyword, which it's like saying where order_date.year equals 2012. But this allows you to specify multiple values. So you can say it could be 2012 or 2013 or 2014. It's just a shorthand that makes it a little easier for us to generate the DAX. But it's doing exactly the same thing, right? So let's get rid of that. Let's do one of those time intelligence ones. And that's really actually where this feature came from, right? It's that we wanted to know, we wanted to help people quickly build these year-to-date functions. And it uses this function here. So total YTD, sum sales units, blah, 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 sales order date. And for people who had never seen this function before, it doesn't exist in Excel, they were totally confused by how it worked. It's actually fairly simple. It says, go and evaluate the sum unit sales measure, or in this case, it's like a reference. It's just the column reference wrapped with sum across that date field. But hey, it saves you having to go and learn that. And sure enough, well, you go drop it into a date table, and we start adding these values up as we go through time, and then it will reset at the end of the year. So we just get a typical sort of year-to-date type column. And the great thing is that it doesn't matter what level of this hierarchy I'm looking at, it will keep evaluating it and keep working. I can drill right down into the day level and see day by day it's adding those things up. So I don't need to keep like rechanging the formula depending on whether I want to look at days or months or years or whatever. The other one that I'll do here is this aggregate per category. And this is another really useful one. So let's say I wanted to do, I want to see what my average monthly sales is. Now I could just drag my unit sales column on and just change it to do an average. But that would actually take the average, think about how that statement's going to be evaluated. It's going to go and get all of the underlying rows out of the table and do an average of those. Now my average unit sales on a daily basis are like 2 or 3 units per day. So my average will be 2 or 3 or something. But I don't want that. I want to say, sum the value up to the monthly level and then take an average of that. And that's what these aggregate per categories can do. So if I want to do an average, I'm going to say, sum up the sales first to the monthly level, and then take an average. So we go average X, we have some special magic, but then it's just doing the calculate of the unit sales. Keep filters is the thing that determines, particularly here because we're using a date field, we're doing some magic because we're using our built-in date tables. But the quick measures does all that stuff for you. So you just get, I get the same value at the monthly level, but you'll see now at my quarter level, rather than having the total, I'm actually getting an average, so it's the same as adding these 3 values up and then divided by 3. So you don't have to worry about what level am I working at, and again, I don't have to figure out, okay, well, I'm doing the average and aggregate these things first and then do an average. The quick measure takes care of that stuff for you. And we're going to be adding more of these all the time, so get on the forums and vote for the ones that you're interested in to help.
So of the Excel users, who uses VBA or used a bit of VBA at your time? Okay, who went to university and learned how to write VBA for Excel? Who learnt by turning, someone did, fantastic. And who learnt by turning on the macro recorder and seeing what happened and then worked it out from there? That's what quick measures is, right? So no one's saying it's the end game. What we're saying is it's going to help you get started. And once you start to and I encourage you to get in and try and understand and interact with those measures, learn how it works, and it'll help you on your journey.
One of the bits of feedback I've heard a lot about these quick measures is that people want to see comments in the measures that get generated to help you understand it. And I think that'll be a really useful way of learning it. So we're going to work on that sometime in the future.
Quick measures is just Power BI.
It's just Power BI desktop, yeah. Okay. All right, so that's everything. Thank you very much for your time. Thanks for coming along.